Don't make the mistake of seeing this particular equation for f of x as an f of x equals to, like this might look a little bit complex, but at the end of the day, you don't need to know what the shape is. You just need to realize that if they're telling you this is defined by this is going to have a unique shape, okay? This is going to have some sort of particular orientation when you plot it on the xy axis. I don't know what that shape is. You don't know what that shape is. You don't need to. What they're really testing you on over here is, do you realize that if they're telling you it's given that f of x is decreasing function for this particular definition? Because think about this, if you realize means the same thing as f of x, I'm explaining to you in real time how you interpret this question. Do you comprehend that if they tell you f of x is equal to this has a particular shape that we don't know about, and this has a limited domain? Meaning, let's look at the basic example, okay? So I'm explaining to you the basic knowledge you need to have to be able to interpret this question. If you look at a really basic example of, say, y is equal to 2x plus 6, this is something you could do in your sleep, as in you know what that looks like. You could probably plot that within seconds. Like surely by the time you're doing AS, like, which you are now, you know that 2x plus 6, if you wanted to plot that, it's just 6 over here, and you can just plot a graph like that, okay? Now my point is, this graph goes on infinitely, doesn't it? You're not confused about why it goes on infinitely, as in you can just keep extending. However big you want that graph to be is however long that line extends to. But if you were to change this and you do comma for, as in introduce a specific domain for x is greater than 0, you get that only this part of the graph exists now. As in all this stuff you don't even draw anymore, is it? Meaning the new shape that you would be drawing over here is just going to be 6 over here, and the graph that goes on like this. Remember points? Just basics over here. As in you understand the basic definition of if you have a particular graph equation and they give you a specific domain, you know what it looks like. You have a limited representation now on the xy axis. That's all it does. If you have y is equal to x squared, for example, x squared as is, if you don't give any special instruction, it just means x squared goes on like this forever, doesn't it? But if you do y is equal to x squared for x bigger than 1, you'd have to draw what? There's a reason why it only looks like this now, doesn't it? As in everything below 1, notice that every single point to the left of this coordinate, it's all the x values less than 1. You're saying that x has to be bigger than 1. Remember the basics over here? If they give you a particular instruction, like a very basic y is equal to x squared parabola, smiley face parabola, it's a parabola that goes on infinitely, but if you introduce a condition bigger than 1, you know it only shows this part onwards. Why am I showing you this? I'm showing this so that you make sure, before you attempt this question, you know the basics that this has a particular shape, and it's got a limited representation over here, meaning it's anywhere between a half and another number over here. And between a half and another number, when you plot this, when you only plot this part of the graph, between a half and another number, so if you look at the graph like this, it's x, y, you have a half over here. I'm explaining to you in real time, yes? Like sort of what you're comprehending here, like what do you understand in simple English? This is a particular graph between a half somewhere, you don't know where that ends. You're trying to ask where it ends. You're looking for a missing number. How do you find a missing number? You need some sort of equation involving the missing number. Basics of algebra over here. Do you follow? You need one equation involving a. And you understand that equation involving a is what? That relationship comes from somewhere. It comes from this information they give to you, which is f is a decreasing function. How do you turn that into an equation? What does decreasing function mean? Decreasing, this is where they're testing you on, hey, do you need to be told that decreasing function just means negative gradient? Do you remember that basic? Negative gradient means decreasing function. Yeah? As in, like, this whole time when we're doing this question so far, right? We don't even know what this shape looks like. I don't know what that shape looks like. But I know that if they're talking about decreasing function, I know they're talking about the differentiation of this being negative. Does that make sense to you? They're really just indirectly telling you, hey, can you tell that we're talking about a negative differentiation over here? So does that mean, remember the rule with these types of questions? You just look at the next step. So we already know, okay, differentiation has to happen then. So that's, without further ado, right, we just go ahead and do differentiation then. It'll help. So we go ahead and do that. We don't think too much about it. Just differentiates. You do 3 over 2 times 1 over 3. You know, it's going to be, if you don't know how to simplify that, pretty worrying, but calculate it if you have to. 3 over 2 times 1 over 3 is just going to be a half. Bracket 2x minus 1 to the power of 3 over 2 minus 1, which is going to be a half, times that by 2 minus 2. If you're unsure about how this differentiates into this particular expression, go ahead and watch the section in the document that says how to adapt differential expressions, as in how to differentiate every scenario. Go to that section. I'm just going to assume you know how to differentiate this, yeah? So if you know how to differentiate this, you know you have this, and once you have this, you know this is what represents the gradients. You don't need to be told this can be simplified, which is going to be 2x minus 1 to the power of a half minus 2. Type on your calculator 3 to the power of a half. Type in your calculator 9 to the power of a half. Type in your calculator 16 to the power of a half. You will find it gives the same answer as what? Square root of 3, square root of 9, square root of 16. Meaning to the power of a half, you recognize the same thing as square roots, which is what you do over here. Why? Because when you're trying to adapt expressions, to the power of a fraction looks fucked up, doesn't it? Do we agree? To the power of a fraction looks fucked up. Therefore, without needing to be told, we adapt this, we write this into a different expression that doesn't involve fractions, where we realize the power of a half is just going to be square roots. So now we have something that represents the differentiation over here, f dash of x, the gradient function, f dash of x. And if they're talking about decreasing function over here, they're just talking about what? The gradient over here being negative. Meaning, how do you write that? Isn't that an equation? That's a relationship you can set up now, isn't it? That being less than 0. Because decreasing function just means gradient less than 0. Meaning if this represents our gradient, because you know from basic knowledge of it, f dash of x means differentiation, differentiation means gradient, gradient less than 0. Are you confused about how we got this equation over here? And if you have that equation, you really have just 2x minus 1 minus 2 less than 0. Okay. That's something you can solve now, isn't it? Just looking at that as is, you recognize, you have the awareness, this can be solved. It's 2x minus 1 less than 2. Which is, you can square both sides, can't you? You recognize you need to get the x by itself. You can't get the x by itself right now if it's stuck inside a square root symbol. Therefore, you do 2x minus 1 is less than 4. Why? Because if you square any square roots, right, you get rid of the square roots. This is basics of algebra over here. And that's where you get x less than 5. 2x less than 5, right? One to that side. This is basics of algebra over here. I'm sure you know this. So x must be less than 2.5. Meaning less than 2.5 is what? If x is less than 2.5, where did that come from? It came from a relationship over here. Meaning, what have we really done over here? This is what you've got to realize. X less than 2.5. 5 over 2 is just 2.5, right? Yes? X less than 2.5 is the instruction. It's telling us as long as the number that goes over here is less than 2.5, we're going to get a negative answer. Meaning, x less than 2.5 is how we guarantee what we can describe the x over here to be, so that this whole thing is going to be a negative gradient, or aka a decreasing function. So they're telling us this is defined between a half and a certain number over here. Do you see how this is the instruction we found? Do you see what we got over here? We found that x less than 2.5. I'm explaining to you how to interpret this, as in, hey, we've done the question over here. What do we do with that information to get the final answer? The final answer over here, this is where you make the link. X less than 2.5. That just means as long as the number that goes over here is less than 2.5, you're going to have a negative gradient. And they're defining what? They're saying between a half, because that's the instruction they chose, isn't it? They chose that as long as x is between a half and a certain other number, it's going to be a negative gradient. And you know x less than 2.5 is going to be a negative gradient. Come on. Are you really confused about why a is going to be 2.5? Do you need further elaboration? If you need further elaboration, think about it this way, okay? It's a bit like saying if we were to describe the ideal, I don't know, you might have ideal brass size in a hoe. Could be, you know, B could stand for ideal brass size. Between 6 and mystery number. Okay? This might be my ideal brass size I'm looking for in a hoe. And then your one might be, say, for example, between, you know, as long as it's less than, because I don't know, you might be a weirdo, right? You might just want something as long as it's less than 7. Now, my point is, how do you combine both of these? If we had to find something that satisfies both of us. Come on. Isn't it just going to be... Like, is that not common sense to you? Isn't the condition between 6 and 7 going to satisfy both of us? Because it means your one is going to be less than 7, and my one is going to be at least bigger than 6 and less than a certain other number. Which is why this principle over here, when we found that x is less than 2.5, has to be merged with this, right? Because that's the definition they chose. That's the domain they chose. Oh, a just has to be 2.5 then. See how that works? Okay? And you found that a is equal to 2.5.